Hello friends, welcome back to our new video. Recently, I saw a time machine project by Matt Kyver. As a sci-fi movie fan, I was excited to know how he made it. Although the title Time Machine was given figuratively, the project was a success and it is also a great project for beginner to start with. So, I decided to make my own. As the code and diagram was already given, it was done very quickly and worked perfectly. But as an electronic enthusiast, I was not satisfied with that. By analyzing the diagram and code, I noticed that in the circuit, Arduino's only task is to blink the LED in a certain frequency. Also, I wondered if it is possible to do without Arduino. So, in this video, I will show how I created my own version of the time machine, how it works, and also what is the science behind it. So, let's move into it. First of all, let's briefly understand how it creates the illusion. A rotating fan is fixed at an end. We flash light on it with a certain frequency. When the rotating frequency matches the LED blinking frequency, it creates an illusion like that the fan leaves stuck in the same place without moving. That is, LED blinks again and again when the leaf reaches the same position. This process repeats very fast and we feel it as a freezing effect. The next is to build a circuit. For generating such a frequency, I decided to use 555 IC. For adjusting the frequency, I used a 10K potentiometer with 555 IC. List of all components is in the description. Then I designed the circuit in every circuit. Let's understand how the circuit works. 555 IC consists of 8 pins. In that, the second pin is trigger pin. If the voltage at it reaches below 1/3 of the supply voltage, output pin 3 turns on. Also, when the voltage at pin 6, threshold pin, exceeds 2/3 of the supply voltage, output turn off. The pin 1 and pin 7 of 555 IC connect internally while the output is off and it disconnects when the output turns on. So, while we connect power to it, the capacitor will be in discharged state. And the trigger voltage will be less than 1/3 of the supply voltage. So output turn on. The capacitor gradually charges and the voltage at threshold pin exceeds 2/3 of the supply voltage. Then output turns off. Also, pin 7 and pin 1 connect internally. This results in discharging of capacitor and the voltage reaches below 1/3 of the supply voltage. Trigger pin sends it, output turns on. This cycle repeats. This is the reason for the blinking of LED. The 10K resistor connected in the circuit take part in both charging and discharging of capacitor. So by changing its value, we will be able to set the blinking rate. So I replaced the 10K resistor with a 10K potentiometer. That's all about the electronic part. Next is to test it. The circuit worked pretty well. The blinking rate was easily adjusted with the 10K pot. As a rotating object, I used a DC motor with a cardboard on it. Then the difficult part in the project starts, the adjusting. As the blinking rate of the LED was very fast, it was really a painful experience. But after spending 4 hours, it didn't work well. So I decided to replace 10 microfarad capacitor with a 4.7 microfarad capacitor. After a bit of adjustment, I got a slightly slowing effect. It can be called as a 60% success. As the project was without Arduino, I was happy with the result. If you want to do this project, it is better doing with an Arduino. But through this project, I learned how freezing effect with light works. At least, I was able to understand the physics behind it. So, hope you learned something. So, if you like my video, please subscribe our channel. Thank you for watching.